Good morning, everyone. My name is吴奕心from Physical Therapy Department. The project topic today is about the effect of fatigue on asymmetry of legs and the trunk-hip coordination during roundhouse kick in Taekwondo athletes. Taekwondo is a combat sport featuring sophisticated kicking skills, and the roundhouse kick is the most used foot skill. Previous studies have reported that Taekwondo athletes showed very low asymmetry, and the athletes with lower bilateral asymmetry are more coordinated and more likely to get higher scores during matching. In roundhouse kick, the inclination of trunk counters the balance disturbances induced by the rise of kicking leg. However, the development of fatigue during matching may affect trunk-hip coordination bilateral, despite not being well studied. Therefore, the purpose of our study is to investigate the effect of fatigue on bilateral asymmetry and trunk-hip coordination during roundhouse kick in Taekwondo athletes. The inclusion criteria of our study is red belt or above, which is according to World Taekwondo standard. The exclusion criteria are having major disease, taking extra trainings, and other studies, taking competition recently.
The procedure of this study include preparation, practice, and simulation game test. In preparation, we collected informed consent and baseline information from participants. Next, we plan a motion sensor and partitive gears, as this figure. These motion sensors were planned at low solid thick, sacrum, bilateral thighs, and bilateral legs. Next, in practice, participants were asked to took a 1 minute practice trial, which include 50 kicks. Next, we explain and demonstrate the simulation game test. In the simulation game test, participants took a 2-minute simulation run with 1 minute interval break. Repeat 3 times. In each round, participants were asked to conduct 30 roundhouse kicks. Okay, this video is our actual procedure. Like this, the subject must follow the kick instruction to conduct roundhouse kicks. Our kick instruction includes 3 parts: standing pose, kicking leg, and kick position. In standing pose, we have 2 types: right lead and left lead. Each lead have 50 kicks. This picture shows the left lead. In kicking leg, we have 2 types: front leg kick and right leg kick. Each kick have 50 kicks. This picture shows the front leg kick. In kicking position, we have 3 positions: high, middle, and low position. This picture shows the high position kick. In each round, we have 30 randomly assigned kicks with different standing pose, kicking leg, and kick position. And the interval between the kicks is also randomly. In this sample, the first kick and the second kick is 6 seconds. Next is 3 seconds. Next is 4 seconds, and so on. We measure bilateral asymmetry using symmetry angle. In first figure, we record right and left knee flexion angle during a roundhouse kick. Next, in second figure, we record right and left angular velocities. Next, in third figure, the x-axis is right knee angular velocities. The y-axis is left knee angular velocities. And then take maximum angular velocities in second figure image here. If the right and left angular velocity are the same, the point will be on the 45-degree right. It indicates perfect symmetry. And then put the angular velocity into the formula. We can get symmetry angle. If get 100%, it indicates perfect upside or perfect asymmetry. If get 0%, it indicates perfect symmetry. So the smaller the symmetry angle, the more symmetrical. The larger the symmetry angle, the more asymmetrical. We measure trunk-hip coordination using maximum trunk side bending and maximum hip abduction. This figure shows the one-time roundhouse kick of our subject. The x-axis is kick compression, like 0% is start. The 100% is impaired target. The y-axis is degree. The blue line is trunk side bending. Red line is hip abduction. The red line is knee flexion angle. We mainly take maximum trunk side bending angle and maximum hip abduction angle of peak kick to analyze. This is our baseline information from participants. There are 40 athletes in this study. This is our result. This figure is about a symmetry of hip flexion velocities. The x-axis is high, middle, and low kicks. The y-axis is symmetry angle. The blue one is round 1, green one is round 2, yellow one is round 3. In hip joint, symmetry angle in high kicks is significantly higher than middle and low kicks. And in high kicks, symmetry angle in round 3 is significantly higher than round 1. Next, this figure is about a symmetry of knee flexion velocity. In knee joint, symmetry angle in high kicks is significantly higher than low kicks. Just this. Next, this is maximum trunk side bending angle. The y-axis is trunk side bending angle. Trunk side bending angle in high kicks is significantly higher than middle and low kicks. And in high kicks, trunk side bending angle in round 3 is significantly higher than round 1 and round 2. Next, this figure is about maximum hip abduction angle. The y-axis is hip abduction. Hip abduction in high kicks is significantly higher than middle and low kicks. And in high kicks, hip abduction angle in round 1 is significantly higher than round 2 and round 3.
It is our discussion for bilateral asymmetry. The effect of fatigue on lower limb asymmetry remains undetermined. One study shows fatigue by running significantly increased asymmetry in hip-knee flexion angle. But another study shows fatigue by loaded squatting significantly decreased asymmetry of ground reaction force. So, why are the results of these two studies are different from ours? We speculate that the effects of fatigue on limb asymmetry may vary with muscle type and task. In first study, running uses slow twitching muscle more and is reciprocal in movement. In the second study, squatting uses fast twitching muscle more and is non-reciprocal in movement. But in our study, Taekwondo uses fast twitching muscle more and is reciprocal in movement. Therefore, running, squatting, and Taekwondo are not the same. So the results of these two studies are also different from our finding results. As a consequence, in our study in Taekwondo, fatigue tend to enhance the existing bilateral asymmetry, especially in proximal joint. And the discussion for trunk-hip coordination. One study shows trunk inclination and hip abduction are used to adjust different target distance. In short target, athletes used more hip abduction than trunk inclination, but in long target distance, athletes used more trunk inclination than hip abduction. However, another study indicates excessive trunk inclination will lead to imbalance, kicking force reducing, and having difficulty in regaining posture. So, in conclusion, our results have two parts to show that. Asymmetry part, trunk-hip coordination. At asymmetry part, the high kick demonstrates greater asymmetry between dominant and non-dominant leg than middle and low kick. Asymmetry of hip is more affected by development of fatigue, but not knee joint. The knee joint will not increase asymmetry due to fatigue. And in trunk-hip coordination, in the high kick, the fatigue of hip muscles reduces hip abduction and is compensated by increased trunk lateral inclination. The compensatory strategy maintains kick height at the cost of posture instability and inefficient force production. So, this is the end of our presentation. Thank you for your listening.